Now let us talk about the Laplace transform of elementary functions. Before that, once again, I want to write the original definition of Laplace transform. Laplace of f of t, you can write like f of s also, and the formula is integration 0 to infinity e raised to minus st f of t dt. This is the standard formula where t greater than or equal to 0. Now, one by one, we are going to prove the formulas of Laplace transform of elementary function. So, first one will be f of t is equal to a, where a is some constant. Okay, and we want to find the Laplace transform of this constant. So, the procedure is very simple. Just put this a in this formula. So, what you can write? Laplace of a is equal to integration 0 to infinity e raised to minus st a dt. Now, here a is constant, so we can take it outside. So, a is outside, and integration of e raised to minus st is e raised to minus st upon minus s, and then limit 0 to infinity. Here you can take this minus s outside, so it will become minus a by s. Now we want to put this limit infinitive. Now actually we cannot substitute this infinitive limit directly because it will become improper integration, but it is fine here. You can substitute it, no problem, right? So the answer is take t instead of t, put infinity. So infinitive into something is infinity. So upper limit can be represented as e raised to minus infinity minus. Put instead of t this 0. So 0 into something is 0. So you can write e raised to 0. Now friends, you have to remember one thing, that e raised to minus infinity is 0 and e raised to 0 is 1 always. Always remember these 2 points. Note down it. It is important in mathematics. So here you can write minus a by s into the bracket 0 minus 1. Simplify. You can write a by s. Now this a by s is the standard Laplace transform of this a constant. So if instead of a I am writing 1, so answer Laplace transform of 1 is 1 by s, Laplace transform of 2 is 2 by s, Laplace transform of minus 5 is minus 5 by s. That means Laplace transform of constant is constant by s. We have standard formula, right? And you have to remember this formula for the next lectures also. I am going to use this formula. Now let us talk about second function. In second function, we are going to talk about e raised to at. That is important formula. E raised to at. F of t is e raised to at. So the procedure is same like the previous example. Put f of t is equal to e raised to at in the standard formula. So you can write e raised to at is equal to integration 0 to infinity e raised to minus st e raised to at dt. Now we know that base is same, so you can add the power. So I am doing that operation only. Integration e raised to infinity 0 to infinity e raised to. Now one more thing. I am taking this minus sign outside. So in the bracket you can write minus a s minus a t dt. Now take the normal integration of this form. So you can write e raised to minus s minus a t upon minus s minus a, and substitute the limit 0 to infinity. This term is constant, so I am taking this outside. Now once again the procedure of substituting the limit is same like the previous example. Take t instead of t infinitive as upper limit, take t is equal to 0 as a lower limit. So you can write 1 upon minus s minus a into the bracket e raised to minus infinity e raised to 0. According to the previous concept, e raised to minus infinity is 0 and e raised to 0 is 1. So the final answer is 1 upon s minus a. So friends, once again we have second formula. Laplace transform of e raised to at can be written as 1 upon s minus a. Laplace of e raised to t 1 upon s minus 1. E raised to 5t 1 upon s minus 5. E raised to 10t 1 upon s minus 10. Here, if the sign is positive, the answer contains negative sign. So both the signs are opposite. Is it okay? Right. Now, here, I am going to take one formula to prove as a homework, and that formula is f of t is equal to e raised to minus at. What is the answer? Laplace of e raised to minus at is 1 upon s plus a. I am not going to give the proof of this example. So it is homework. You have to do this. The technique is same like the previous example, and here the sign is negative of the function, so you will get positive answer. Okay, so take this example as a homework. Okay, now let us talk about the next formula. F of t is equal to cos at. Formula number 4. F of t is equal to cos at. Put this in the formula. So Laplace of cos at is equal to integration 0 to infinity e raised to minus st cos at dt. Now this integration is little bit interesting. You cannot find this integration directly. You should know the formula of this integration. What is the formula? I am giving you. Note down this formula. Integration of e raised to ax cos bx dx is equal to e raised to ax upon a square plus b square into the bracket a cos bx plus b sin bx. Friends, note down this formula. I am going to use this formula in this example. So first of all, compare both the formulas and tell me what is a. A is equal to minus s. What is x? X is equal to t. And what is b? B is equal to a. Compare both the form. A is equal to minus s. B is equal to a. And x is equal to t. So just compare both the formula. You will get final answer. What is the answer? E raised to minus st upon minus s square plus a square into the bracket minus s cos at minus s cos at plus a sin at. Now we have to substitute the limit also. So substitute the limit from 0 to infinity. Now one more thing. I have previously seen many students, they just substitute the limit in this bracket. They forgot to substitute the limit in this form. So you will get the wrong answer. Okay, so you have to substitute the limit in the whole form. Remember. Okay, so first of all, note down this so I can rub that. Okay, now our next target is to find the limit of this one. So what is the limit? Before substituting the limit, just look at the example very carefully. Forget about this bracket whenever you are substituting t tends to infinity and focus on this term. Once again, you have e raised to minus st. So if you are taking t tends to infinity over here, it will give you e raised to minus infinity. That means that term will give you 0 answer, and 0 into something, you know that 0. So upper limit is 0. Minus in lower limit, instead of t, take 0. So we'll get e raised to 0 upon s square plus a square into the bracket. Now think about this form. This is very simple logic. You know that cos 0 will give you 1 answer and sin 0 will give you 0 answer. So 1 into minus s, that means minus s plus 0. Simplify this one. E raised to 0 is 1. So the answer is s upon s square plus s. So friends, you have new formula of Laplace of cos at. Laplace of cos at is s upon s square plus a square. Laplace of cos 2t, s upon s square plus 4. Cos 3t, s upon s square plus 9, and so on. You can derive all the formulas, right? So this is once again interesting formula. Okay, fine. Now let us talk about the next formula, that is f of t is equal to sine at. The procedure is same like this one, but the integration formula is little bit different. So we have to take care of this concept. So here, the formula number 5 is f of t is equal to sine at. Laplace of sine at can be written as integration 0 to infinity e raised to minus st sine at dt. The formula of integration is integration e raised to ax sine bx dx can be written as e raised to ax upon a square plus b square into the bracket A sine bx minus b cos bx. Now compare the formula of this one and the formula of previous one. This term remains as it is, but this term will be different. Instead of cos, you have to write down sine. Instead of sine, you have to write down cos, and this sign is also different. In the formula of cos, it is positive sign, and here it is negative sign. Okay. Now let us compare this formula with our example. So once again, a is equal to minus s, t x is equal to t, and b is equal to a. So the answer is e raised to minus st upon minus s square plus a square into the bracket minus s sine at minus a cos at, and then limit, that is 0 to infinity. The limit substitution rule is same like the previous example. Okay. So how to substitute the limit? Here once again we have the term e raised to minus st. So whenever you are substituting that limit, this term will become 0. So upper limit is 0 like previous one, minus lower limit is e raised to 0 upon s square plus a square into the bracket sine 0 will give you 0 answer, and cos 0 will give you 1 answer. So this first term will become 0, and the second term cos 0 is 1, so it will give you minus a. So the final answer is a upon s square plus a square. So what is the Laplace of sine at? Laplace of sine at is a upon s square plus a square. Laplace of sine 2t, 2 upon s square plus 4. Laplace of sine 5t, 5 upon s square plus 25. So you have once again new formula. Is it okay? Right. So I think the concept of how to derive the formulas of sine at and cos at is quite clear to you.